Okay, in this video, we're going to talk about worm gears. So, with worm gears, it's a little bit different. So, we talked about spur gears last time. With worm gears, you typically have two axes that are perpendicular to each other, but they don't intersect. So, the two lines are in different planes, so they never intersect. These are known to give very high speed reduction. So, in other words, you could generate a lot of torque depending on which side of the gear you're on. So, you'll see this in like guitar applications where you're turning the strings. They use some type of worm gear mechanism. But in terms of how you choose it and how you set it up, it's very similar with the spur gear in that they have like gear pitches that you look at. Sometimes when you get the worm, so you can see this part, the small part. Sometimes it'll come with a shaft, so that can make things a little bit easier. So it just depends on what you want, and you can see that the number of teeth can go up pretty significantly, up to 100. So that could give you a lot more mechanical advantage. So here we're looking at, let's just go with a 12. Choose this one, 12, and then you can see the speed ratio that this will provide. You go with a 60 to 1. Okay, so the gear ratio will pretty much tell you how much speed or torque reduction. But let me just go ahead and download this in our worm gear video, folder, I should say. And I will download this one as well. But we could just take a look at this. So we see that there's a pitch diameter for this one. And then for the worm, you can see this one also has a pitch diameter. And as long as the diameters line up, then that's really all you need. Okay, so open up this one and we'll open up the other one. Okay, so this is how it will look like. And if I open up in assembly, let's pin this. So we have our worm gear and then our worm. So we were saying that it's perpendicular. So if I try rotating this, okay, it'll look something like this, and the gears will sit inside like so. Okay, so I'm gonna mate one of the faces to a plane, or at least parallel to one of the planes to make it line up a little bit better. So maybe parallel to the right plane. Okay, so also notice that this is already keyed for you. So you know that you don't have to worry about pressing it in like the spur gear. Okay, so now I could drag and you could kind of see where the gears should fit in, right? This gives you a better visual. So let's actually use the numbers to see where they should line up. So in practice, you could have some structure maybe that goes up and around. But here, let's make like some plate to hold it. So I could sketch on the top plane some structure. And this gear was how big? Let's see. So if I just draw a quick circle over this, I could see that this is about um, the whole thing is maybe like 6, 7 inches. So we'll play by ear and adjust the size later. But let's just make this 7 inches for now. Maybe a 7 by 7 block. I could make this 0.25. And we'll call this, I forgot to change folders last time, but here we'll call this worm gear block. And it looks like a plate now, but I'll add some other dimensions later on. Okay, so this is fixed right now. I'm gonna float it. And on this side, I'm gonna mate to maybe this face. And then perhaps I'll have some structure that will hold on to the worm. Okay, so just gonna make a hole right now for this 0.625. I'm gonna look at it from the top. So if I sketch this, let's make it slightly not centered, so just a little bit down. And let's add a center line. Could dimension this down maybe 0.5 inches. And we could use the bearing rules that we did earlier. We could apply that we did in a spur gear here, but for this video, I just want to show you the mating part of it. So we have the main part will be rotating here, and then um, we know that this is the part we have to figure out, right? So if we look at this face, one thing to note is that we want to see if there's maybe like a center plane here. So this has a front plane, which is not what we want. So we'll click these two and then create another plane down in the middle. So now we could take that plane and then if we look at this block here, we could see that there should be a center plane, and then we could mate it to the plane we just created. So now it's centered, right? But the next part is um, it's centered, but we want the direction or how low to go to be correct. Let me float this gear so it can rotate. And I'm gonna fix this plate. Okay, so we want to see how far down it needs to come to mesh up correctly. And from that, we will use the dimensions that we got here, right? So we know that this is 1 inch pitch diameter, and then this is 5 inch. So nice round numbers makes our life easier. So what that tells us is we could create maybe some axis away from there, or um, basically, if we were to sketch this, just going to do a quick sketch on here. So if I sketch out, let's make this like 5 inch. And then if I get the center of this, so we know that the pitch diameter of that is 1 inch, then we know that the center, technically this should come down. So I'm gonna draw should actually come down a little bit lower. But if I go back to the sketch got messed up, but this should come down a little bit more so that it's in contact. And we could measure that. So this is zero point 0.5, 1 inch. So half of this will be 2.5, and then half of 1 will be zero point 0.5, or yeah, 2.5, 0.5. So it should be 3 inches from the center. So we could make axis, or we could also just let's make like a structure here. That's like another way. So I'm gonna create a block, and then maybe we'll extrude boss this, or let's first center that. So this should be 3 inches away. 3 inches from should be from the hole down here. So and then we can make this maybe 1 inch. And let's extrude boss this to be some structure. And then here we could maybe make a cut. So I'm gonna dimension this to be 0.5, and then I can make this 0.5, and I'll have some distance here. Who cares? 0.2. I'm just gonna make a cut through this up to next. Okay, so this diameter here is 0.5. So I could sketch something. And in practice, this may be a separate part instead of a single part, but I'm just making this a single part for now. And we'll figure out the height later, but let's just cut everything for now. So because if I go normal to this, we know that this has freedom to move, but we already know where that should be, right? It should be in the center. So if I open up this, I could create a plane that's like right in between the two. And then if I come back here, I could see, we could get an axis. That might be better. So if I open this up, I could put an axis down in the middle. So now that we have our axis, we could choose this axis, and then we could mate it to that plane we just created. Okay, so this will allow the gear to be in the right plane. And then we can now measure this distance, which we find is 1 inch. So we know that this should be 1 inch from the bottom. We may actually have to make it bigger, but we will adjust accordingly. So this is going to be 1 inch. Obviously, this is too small, so we could extrude boss this to be maybe 2 inches or 1.5. Okay, so now if we come back to our assembly, we see that we can now align this to this hole, and that should be meshed correctly now. Okay, so we can have a shaft that goes inside here and all that good stuff. So Let's see if the mating gear here. So the ratio we had was, this is a 60 to 1. So we're gonna mate this with this, go to the mechanical mates, and we'll do 1 and 60. So if I rotate this, might have gotten it mixed up. Let me see. 60 to 1. No, I think I had it right earlier. So if I edit this again, 160. Yeah, I don't know why the teeth is not lining up. Um, but based on the data sheets, it says it's 60. So maybe it's just with worm gears it doesn't like, but this is how it should look like. Okay, so if you found this video helpful, give a like and subscribe, and I'll see you in the next one.